What do all of these things mean? A, B, C, D. So let's go back to the start. Classification. Classification is basically taking a set of real numbers in at the start of your problem and outputting a set of integer numbers at the back end of your problem. So what might that look like? It means that the output format of the data looks like a category. Let's call it binary, right? So in this case, we have red X's and blue zeros. And the input in this case is a sort of two-dimensional real space, the axes. And we want to learn a system that says, if we get presented with a new data point, in this case, black squares, what are they? And you go back to, I guess, the simplest thing you might do in terms of partitioning a space. So all a machine learning model is doing is sort of partitioning some imaginary data space in a variety of different ways. And so the simplest thing we can do is draw a line through. This separates, right? If we're on the top side of the line, then we're a red square. And if we're on the bottom side of the line, we're a blue triangle. And if we get a new data point and we're underneath this line, then we are a blue circle. Did I say red triangle? Blue triangle? Whatever. Here we should be a blue circle. But the question is, is that correct? So we end up with this generalization problem, right? This is another potential model, which still gets our original data completely correct, right? But now this new data point is a red cross. So the model we're learning has a whole load of characteristics, like where does it get things right, where does it get things wrong, how well does it generalize to unseen bits of data. And most of the time we get really messy kind of answers, right? Which is actually that our real data looks like something much more convoluted somehow, right? And so when we are looking at how to measure the performance of these systems, we'll go into something called a confusion matrix and a ROC curve next week. But the idea is we're balancing up how well it is working in various parts of the state space of the data.